Well, dear students, the next topic is the transmission line equation. This is a very important topic and it is a very lengthy derivation. Please go through it carefully. So, the question will be like this: derive transmission line equation or derive the expression for sending end voltage and current in terms of receiving end voltage and current on a transmission line. So as we know, this is the cross section of a transmission line. Consider a transmission line equivalent circuit of length ds. This is a small cross section of an infinite length transmission line. Let the current and the voltage at receiving end is ER and IR, and S is the distance to the receiving end. So if S is equal to 0, then what is the voltage and current? And if S is equal to L, L is the length. If S is equal to L, what is the current and voltage? This is what we are going to derive in this video. Here, the resistance of small cross section length ds is, let us say, RDS, and inductance LDS, and capacitance j omega L ds, and the conductance of length ds is GDS. If the voltage is applied at the input side, then the current flows from the input side to the output side, and as we know, there is a voltage drop across this cross section dE. The voltage drop across the cross section dE is given by dE is equal to, where E is the voltage that we have applied, dE, the differential voltage at this cross section of length ds, dE is equal to, as we know, V is equal to I into R, so the series impedance is RDS plus j omega L ds into I. From that Ohm's law I have written. Here I will write negative sign. That negative sign indicates the voltage drop across the receiving end will be less than the source end. As we know, if the voltage across the output side is greater than the input side, then it is against the law of conservation of energy. So the voltage appear across destination end will be less than the voltage across a source end, hence I have written a negative sign. Therefore, dE, if I take ds common, then dE by ds is equal to minus R plus j omega L into I. Let us say this is equation number 1. Similarly, output current dI is given by the dI is equal to, as we know, I is equal to V by R. 1 over R is nothing but admittance. So minus of G dot ds plus j omega C dot ds into E. So GDS plus j omega C ds into E. Again, the negative sign indicates some of the current flows in this shunt arm. So the current appear across the destination end will be less than the source end. Therefore, again, by taking ds common, di by ds is equal to minus of G plus j omega C into E. Let us say this is equation number 2. So differentiating equation number 1 by differentiating equation number 1 with respect to a small differential length ds with respect to ds, then equation number is d by ds. So differentiating this equation, d square e by ds is equal to minus of r plus j omega L, where I'm going to differentiate with respect to s. So di by ds. So from equation number 2, di by ds is equal to minus of g plus j omega c into e. Thus I will substitute here. So d square e is equal to d square d wait d square e by ds is equal to minus of r plus j omega L minus of r plus j omega L into di by ds, but di by ds is minus of g plus j omega c into e. So minus of g plus j omega c into e. Therefore d square e by ds is equal to minus into minus plus, so r plus j omega L into g plus j omega c into e. Therefore d square e by ds square, sorry, this is ds square, this is ds square, again here also it is ds square, is equal to, as we know, r plus j omega L is a series impedance and it is denoted by z, and g plus j omega c is the shunt admittance and it is denoted by y into e. Let us say this is equation number 3, where series impedance is equal to r plus j omega L and shunt admittance is equal to g plus j omega c. Let us consider d by ds is equal to m, and d square by ds square is equal to, if d by ds is equal to m, d square by ds square is equal to m square. For simplification and to find the roots of differential equation, I am going to consider, let us, d by ds is equal to m and d square by ds square is equal to m square. Therefore d square by ds square is equal to m square. Therefore m square e is equal to series impedance shunt admittance e. So e gets cancelled. M is equal to square root of z y. The general solution, as we have studied in mathematics 3 m3, if the roots are real and distinct, then the solution of equation can be written as the general solution of the differential equation or e is equal to constant into e power square root of zy into s, where s is the variable that we have considered for a distance s. So plus b into e power minus square root of zy into s. Therefore I is equal to constant c e power square root of zy into s plus d into e power minus square root of zy into s. This is a general solution of the differential equation if the roots are real and distinct. So let us say this is equation number 4 and this is equation number 5. I will continue in next video.